What's up guys, Shawnthebro here, and today we're going to be going over advanced projectile techniques. Specifically what I'd like to be going over is projectiles colliding with each other and how they can interact. So before, projectiles would actually phase right through each other and wouldn't have any sort of collision. We never set it up and that's perfectly fine, but we probably should set up at least some collision. At the least, one of the projectiles probably should eat up the other. Now, in some cases, such as Mortal Kombat, I know this is not the case, so by all means, feel free to skip this or choose which ones are going to interact this way. I'm going to allow it so that we actually check some booleans on the projectile to determine if we want this logic to occur. This will allow us to have the best of both worlds, where some projectiles can destroy others and some will pass through each other. So in this case, let's start with our fireball. If I can do this right, both fireballs will come out, hit each other at the same time, and explode. The players don't take any sort of damage because the fireballs collided before they got to the actual player and other character. We may also want different projectile types to interact with each other, such as this charge attack, this thunderball as I call it. And I did that way too late, so that's not going to work. Let's try to see if I can do it again. I have to get my timing down. I almost tried to... Nope. It's not right. I'm feeling it this time. You ready? Boom, there we go. And the mutant negates damage. Player 2 negated all damage because the fireball blew up the thunderball. Now this is pretty slow because I'm controlling both characters, but in a lot of times, in a lot of cases with the different fights that you may be fighting a zoner, you might be shooting projectiles back and forth at each other, and sometimes they'll eat each other up, sometimes they'll cancel each other out, sometimes one will overpower the other. We do have this one as well, if I can remember the input for it, which that's a homing attack, and it's really overpowered right now. However, that one I don't want to be destroyed by a projectile. Like, if a fireball hits that, I don't want the projectile to cancel it out. So I'm going to show you how we can do both those methods with simple booleans that we already have on our projectiles. We don't even have to add anything to our projectile to actually make it work. Toward the end of this episode, we'll also be covering the other hitbox changes that I spoke about in the NBPs. So we switched over our hitbox data and our move data to use the data tables here and the structure. And I debated whether I wanted to use the structure data or just the class variables. Well, we were using the class variables before, and again, what I said last episode still applies. However, I think for the purposes of the series and being clear and concise, anytime we want to update hitboxes, I only want to have one method. So I'm going to swap out this logic with the struct logic, and I'm going to show you how you can do that. It's not required that you'll do it, but I do want to show it off, and that way we will have a clean method going forward as opposed to having to decide between the two. So anyway, guys, to get started today, we're going to hop into the blueprints. There's actually no code in this episode. It's blueprint only because we're just modifying the collision on our hitboxes for projectiles and how we can decide what we want to do with each projectile as it collides. And the stuff I just mentioned in the NBP. But if you'd like to get caught up and see how we've done our different projectiles, our hitboxes, and all that sort of logic, I'll leave this playlist right here, top right corner. It's the entire playlist for the fighting game tutorial series. It'll lead you to every episode on how we got to this point, and it'll stay current, so any episodes we add later for future installments, you'll be able to see them there as well. You'll also be able to check out this iCard right here, where we first did projectiles. Could very much come in handy for this episode, so if you haven't done it, I'd recommend it. But otherwise, let's get started. So, first thing we're going to need to do is open up our Hitbox Actor BP. For me, this is in functional blueprints, but you can put it wherever you want, doesn't really matter. And this is essentially an object that has a static mesh component that we call the hitbox. We have a bunch of functions up above that determine what we do with this hitbox, such as, oh, it collided with this player. We want to deal damage in this direction, you know, this number of stun frames, all that good stuff. We also had this part down below, on component begin overlap with the hitbox display. And we determined if the hitbox type was a projectile, then we did logic. This is where we want to alter, because we're only worried about projectiles, and the only time we worry about this specific on component begin overlap is when we have a projectile, because the projectile is going to be launched independent from the character and is going to be moving. So if this hitbox collides with another hitbox, we want to make sure that we either cancel them out, or at least, at the very least, determine what logic we want between both those projectiles. So everything in this you can keep. I've actually just moved it over. Okay, everything here has already existed. Nothing has changed in any of this highlighted logic. So you probably have this huge set of logic right here. And I know it is quite massive, but I'm not going to be covering it today because I have episodes on that. However, we do want to add something first, and this is what's going to actually deal with the projectile collision logic. So before, we were checking the hitbox type, performing a switch on it, and if it was projectile, we were going directly to this node right here, where we were casting the other component to the static mesh component. If this succeeded, we were checking to see if we could get the component tags and see if the substring HB was in it. HB stands for Hitbox in this case, so essentially what we were checking is if the component we collided with is a static mesh component that has this tag. If it does, we know it's a character, and that's how we were dealing our damage. However, we can collide with things other than characters, of course. So say we collide with another projectile. In this case, this is how this is going to work. So if we collide with if we are a hitbox type of projectile, and we collide with something that we can cast to a default projectile BP, then we want to go ahead and say, okay, this is two projectiles that have collided with each other. So now we can perform our projectile collision logic. And let me show you exactly why I set it up this way as well. So we are in our hitbox actor BP. The way our system works is that a hitbox gets attached to our default projectile BP. You don't actually need to open this up, but I have this default projectile BP, and this is what has a hitbox attached to it. It gets spawned into the scene, the correct type, not the default, but for example, if it's the horizontal, this is my fireball. So the fireball will get spawned into the scene when the player performs the command. And then a hitbox will be spawned and attached to that projectile. That comes from the NMBP and some of the other logic we've set up regarding projectiles. Now, when the hitbox has an overlap collision, we can grab the other actor to determine what type of actor it was. Now, we were using the other component before because we were checking against the static mesh component on the player. It would be fine to check against the static mesh component on the hitbox as well. It's up to you. However, in case there are multiple things that have static mesh components that could be flying around, such as even visual effects or stage things that could come into play, we might not want to check that sort of logic on them. So I've been very careful to make sure that the object we were hitting is another projectile. It's not required that you do this necessarily. Again, you could check the component, make sure it's a hitbox type, and make sure the owner was one of the default projectiles. Either way, I like this method more because I know for sure it's going to be a projectile when I hit, but really that's just because I don't need it to do anything else right now. In the future, we may want to update it. So what I've done is I've checked to see if the other actor that we collide with on this hitbox display, or our static mesh in our hitbox, can cast to the default projectile BP. But it won't be able to, because the other actor that we're colliding with will be the hitbox actor. Regardless if it's the mesh or not, it's going to be the hitbox actor. It's not going to be the projectile, because the projectile itself does not have collision. However, the hitbox is attached to the projectile. In this case, for the projectiles and the hitboxes, the owner is actually the character, so that we know who dealt the damage and to keep up combo logic and things like that. However, one thing that we can always use to get the actual actor that we care about is this get attached parent actor. So if you drag off other actor, remember this that I have right here is the hitbox actor that we collided with. So then if I get attach parent actor, I literally get the actor that is attached, or that is basically the thing, the other actor or object that the hitbox is attached to. That's what this stands for. It is different from the owner, as I just mentioned. However, this is going to be our default projectile. So now we have to cast it to a default projectile to make sure. It's always worth making sure, because having an attached parent actor does not mean that it's a projectile. But this is what our projectile is going to be. So we drag off this, we cast it to our default projectile. Right here. If the cast succeeds, then there's other logic we have to do because I'm passing it in, but don't worry about that. We'll do that right after this next part. But if it fails, we're just going to bring it down here. And then it's going to enter all the logic that we already had set up in this function. No further changes are needed. Now going back to what I was saying, if it succeeds, we cast to hitbox actor BP off of other actor. See that? So, as I said, this other actor is going to be the hitbox actor of the other projectile. So, I'm casting it to a hitbox actor BP just so we know the exact type it is. Assuming it succeeds, then I use it. I pass it in, as well as the default projectile reference, to this new function that I've made. Okay. And this is where we're going to handle how we want to cancel or determine which projectile has priority, or if they're going to pass through each other, if they should play effects when they collide with another projectile. All these sort of things can be determined in this function. So I know there's a lot of lines in this one, but long story short, other actor, get the attached parent actor, cast that to your default projectile. If the cast succeeds, we then cast the other actor into the hitbox actor. If this also succeeds, then we know we're ready to go, and a collision between two projectiles and their hitboxes has occurred. Then we're going to make a new function right here, plus function. I called it perform projectile collision logic. I've then added two input parameters, which you can do so by clicking plus new parameter. I made one my default projectile BP and one my hitbox actor BP. So it's as simple as this. You can just look up the class type. For example, default projectile BP. Click the object reference and then name it other projectile ref for other projectile reference. Then you have hitbox actor BP, which is the same way. You just search for it, and then I named it other hitbox reference. All right. Now let's go into our perform projectile collision logic and see what we've done in there. This is a big function. There's quite a bit that we're doing, but it is important that we cover all of our cases here, because there are a lot of different things that could happen if we aren't careful and we destroy only one of the projectiles or destroy only one of them properly. I don't know why this won't straighten. It's kind of weird, but okay. Regardless of that. So here is our function. This is what you'll start with. And we're going to do logic that's pretty similar to what we did when the projectile collided with the opponent. But it's not quite the same, because we do have to deal with the logic for both projectiles, and the order is kind of important as well, because we don't want to destroy one before the other if we need access to them both still. So we're going to be careful when we go about this. But we're going to actually look at the other projectile reference first, and determine if we should display the hit effect. This is important because this hit effect is not like our VFX for colliding with an opponent. It's actually used to determine if a collision occurred where the projectile is going to go into, that explosive effect. So it doesn't really matter. It doesn't have to be, oh, I've collided with my opponent, I'm going to actually perform this. This is if we've collided with something where we want the visual effect to occur. You saw when the two fireballs collided, the flames basically grew. It's because both the projectiles actually exploded and made like this large fire. Same thing happens on the character, but it's important here too, because say we have an effect and say two projectiles collide. One should be destroyed, one shouldn't. Well, the one that's being destroyed should probably spawn the effect and the other one should not. It's not always the case, but you could see why, you know, you could have varying cases here, and I'm trying to account for all of them. So first things first, let's check and make sure our other projectile reference, let's see if it should display a visual effect when there's a collision with this other projectile. You just get the variable that we already made. This is a custom variable we made earlier in the series with our projectiles, and I bring it into a branch. If it's true that it should display the hit effect, we want to spawn the emitter to display the effect. Now, one thing I can already tell you that I should have done that I didn't do is that if it's an effect, or if it is one that should not display the effect, we can still go on to the next branch. It shouldn't necessarily end the logic here. In fact, it definitely should not. So this is what I'm going to do instead. If it's false, it's going to meet up here anyway. So if it's true, it displays the effect and then goes to the next branch. If it's false, it just goes to the next branch. It skips the effect. Okay. And this effect is, again, something we set up in our projectiles, but essentially off of our projectile reference, we have a hit effect variable. It's a particle emitter. And then from there, it's really simple. What we can do is actually grab the other projectile reference, get actor location on it here, and then spawn emitter at location. And then pass in your location and pass in your hit effect, the emitter template. Anything else you want, you can manually change, but I didn't need it, so I left it alone. Now, this one is more important. That was for visual, and it is important, but it's not game breaking. This one is very important. This is the next piece of the puzzle here. So, just like we were talking about with hit effect, one projectile may want to be destroyed upon collision with anything, and one may not. Like the rising tornado move that we have that I said was really powerful and overpowered earlier, when you use it, you don't want to destroy it, say, if a projectile hits it. So if that's the case, not only should I not display a hit effect when something collides with it, but I also should not have it be destroyed upon collision. The fireball, however, will probably be destroyed upon collision with that effect. So with that in mind, then we also have to check this boolean that we have on the projectile reference called should be destroyed upon collision. Then we do a branch on that. If it should be destroyed, we automatically destroy the other projectile ref. When destroying this, we can also just flat out destroy the hitbox actor. Well, I have the hitbox reference here. So after we destroy the projectile actor, I check, is actor being destroyed? And I made a minor mistake here with copy and paste actually. So let me fix this up, because we should be checking if the this actor is being destroyed for this part. Okay, and then if this actor is being destroyed, then we can skip trying to destroy it again. But if it's not, we want to make sure we clean it up as well. Once this other actor has been destroyed, we need to go and look at the logic that is on the actual hitbox here. Self. Not the references, but self, this projectile. We're handling both collisions in this case. And yes, both hitboxes and both projectiles are going to be calling this logic. That's why it's a good idea to check if other actor is being destroyed. So, I'd recommend doing it even here. I did not do it here, but it's probably a good idea since it is being called from multiple areas. So if I get rid of this guy and just move everything over. Okay, and I just moved it over, so now I can just add this just to be super sure. And we'll want to pass in our projectile reference. That's this top one here. Okay, and it's that simple. If it is being, actually, if it's not being destroyed, destroy it. Because it should be destroyed at this point. So if it's not, that's an issue. However, if it is being destroyed, then we skip it. We don't try and destroy it again. That'll actually cause errors. Clean this up a little bit, and now you can see what it looks like. So we check if we should display the hit effect. Both cases are taken care of. We check if we should destroy it upon collision. Both branches are taken care of. Then lastly, we check again if we should destroy upon collision for the hitbox actor specifically. Both branches are taken care of. Then we go to the last section here. Okay. So this is ripped basically from the where we were destroying the hitbox at the end of this function, this event, which is right here. We were getting our attached parent actor, checking if it was valid, setting enable collision to disable it, then grabbing the default projectile off of it, determine if we should display the effect or not. If it's true, display it. If it's false, go to the next area. If it should be destroyed, destroy it. If it's false, then ignore it. Okay? So you can copy this whole section right here, if you'd like, and paste it in. But we'll go through it really quickly in case you just want to write it again. And it might help you get a better understanding of the logic if there's any confusion still. So basically, remember we are in our hitbox actor BP. So if we get attached parent actor on self, we're getting the attached actor that this hitbox is on. So if we're a projectile, which we determine based on our hitbox type, which we set at a different point, then we know we'll get a default projectile here. I was checking for validity. So we check for validity first, then I was disabling the collision. I was casting it to a default projectile BP, and then we're basically going through the same motions. I grab the should display hit effect off this. If it's true, I spawn emitter at location with the hit effect and the actor's location. I'm going to do that because I think it's cleaner. If it's true, we spawn the emitter, and then we go to this branch. But if it's false, we skip and go and check if we should destroy it when collision occurs. If it's true, we destroy it, and then we make sure that this actor, the hitbox actor, is not being destroyed. And if it's not, destroy it. If it is being destroyed, then ignore it. So I know this logic is kind of complex. You can see I even made a few mistakes while I was actually writing it. And there's going to be a lot of different types of projectiles and different cases between these projectiles. So feel free to edit this to your needs. However, this should do basically all the logic you need as long as you set these two booleans. The only thing that I can think of in the future that will be absolutely required will be if certain combinations of projectiles can be ignored and other ones can't, we can use a table or a map to actually determine what projectiles cancel each other out or what projectiles beat other projectiles essentially. This is something we can absolutely set up, and it actually won't impact any of the logic we already have. It'll be an additional thing that we check first, and then we'll go into the appropriate logic regarding that. So as far as I'm concerned, this is pretty solid, and we'll be able to do everything that we want with our projectiles using this method. Okay. With that, you should be able to cancel your projectiles and choose which ones get ignored, which is pretty important stuff. It can really change the feeling of the game, even if it doesn't feel like it. It basically determines what action you're going to perform when a projectile is coming your way, or when you think the character or the other player may be ready to perform a projectile. Now, let's also quickly go through the functions in our NMBP that require these class variables to become these struct variables instead. So without getting into the crazy logic that is in here, because there is quite a bit in here and it's, it can get a little hectic, all we're going to do is take it one step at a time. I'm going to clear out the appropriate locations and we're going to just go through it together. Okay? So this is my create active hitbox function. So what we can do in here is we can look at all the class variables that we set, such as hitbox type, hitbox height, hitbox damage, hitbox location, hit stun frames, block stun frames, pushback distance, and launch distance. Technically, the rotation and scale can be edited here as well. I'll get into that in a minute. Should cause ground bounce. And that's everything. So if we want, we can flat out delete these. Okay? We have to remember what each one is. Luckily, we know that they were set, so I can just follow the node. Like, oh, this is the hitbox type. Okay? Now let's take a look at our struct logic and how we can set them through the struct when we're using the data tables. So we have this hitbox. If I drag off my hitbox actor BP, I have this hitbox data, and we're going to get it. I'm going to do it above here so we can just see it without any confusion. Here's hitbox data. We can now break this or split it, either way, to see the things inside. However, what I'm going to do instead is set the members, because I want to be able to set all these things. And you can actually set them all in this one node if you'd like. You could set them individually in separate nodes, or you can set them all in this one node. We're going to try and set them all in the one node so that we can keep it nice and clean. However, some of the logic may be a little bit hard to clean up, so I'm going to do this live with you, because I think otherwise it could be very, very messy, very confusing. So I'm going to try and move this over like this. And I'm going to just basically slide this down so that everything is in the correct spot. You don't have to follow everything I'm doing exactly or directly or anything like that. I just would like to be able to put this in for you. So if we put this here, for example, I think that's straight. Yep, looks pretty good. So you can see all this mess that we had before. Actually, really, we should put this after this even, because we want to know what direction to spawn the hitbox. And there's going to be two different types depending, one to the left or one to the right. And based on the value here of this branch, I'm going to determine how to set members. This is a perfect example where we can use the select statement, because instead of having two set members where we have to set all the data in each, we can have one and just use a select here. There are some things I don't enjoy about select, but there's nothing actually wrong with it. There are some performance changes, but really it's just essentially a glorified if or select statement or switch statement. So it's not a big deal here because we're only using it with these two instances. So instead of using this branch, I'm actually going to use this select here to clean things up. Okay, so maybe it doesn't, maybe it shouldn't be that close. One to the hitbox data, because the hitbox data is a variable we made in the code last time when we were going over it for this structure. We have this f hitbox data structure now. It has all of these variables, which are now struct variables as opposed to the class variables. So you can see I have all the same variables in the class. And we're basically trying to clean this up so we can just use the structure. But this f hitbox data is a hitbox actor variable, and that's where we're accessing. That's what we're accessing to grab all these values from. And now we're going to go through and we're going to set each of these. So this might take some work here, but we're going to take type, height, damage. Then we have all these ones underneath as well. So I'm going to disconnect the transform and scale for the time being. We can also disconnect this branch at this point. And now we're going to clean all this up. So we should really shrink this down to where they're pretty much all in the same spot. That way we can put them into the node here. All right, so hit stun frames. It's going to go into hit stun frames, block stun frames, the block stun frames, pushback distance, launch distance. Okay, right here gets a little bit tricky because before in the class variable, we only had this F vector hitbox location. In the struct, I actually made an F transform. And this is because we were setting our rotation and scale in the hitbox anyway. If we're doing it through the data table now, we should be setting this all at the same time. I'm going to then pass the data that goes into this for the rotation and the scale into here. That way all that data can be determined through the data table as well. So I'm going to actually right click and split the struct pin here. We're going to take these are in a slightly different order because of the way it was split, but we have rotation and scale here. Then we have this location was already split so that we could do the math on it. So this select vector here is going to go into the location. Okay, rotation is going to actually come up here. Scale is going to come up to the scale, and then these booleans still work as intended. And now we've set all of our members in the hitbox data. Okay, so everything's set in there. We still want to do the rest of this logic. Bring this over here. And just like this, we have a struct out on the set members. Well, we can split that again. It becomes this huge node, but then we can pass in the data directly from the structure. Okay, so if we do this, but there we go, perfect. And now we still want to use this hitbox actor BP here when we're calling set actor rotation and things. This is intended. We don't want to just set the members in the hitbox data. Like we want to set the rotation and the scale, and we do want to set these things. A cleaner way to do it, I think, would be to actually go like here, here, and like maybe give this some breathing room or something. Okay, should be good enough. And then we're going to pass in the data that we need. So for the rotation, I'm passing in the rotation. For the scale, we'll pass in the scale. Okay, this branch is actually the should attach branch, because this was determining if we were going to attach our actor, our hitbox, to our character, such as for our hurricane kick, where the hitbox actually follows us around. Then we go into the standard logic we had, and there we go. In the hitbox actor BP, we've never changed the variables. Remember I mentioned this before. So I did this last time. But we have this hitbox data variable. And we can now select this and see what's in it. Or we can right click on it, split the struct pin, and get all the values like this. This is what it looks like when you're getting it and not setting members in it. Well, now if we're not setting the variables that we need to cause damage and to deal damage, then we need to use this struct instance instead. So instead of using our standard variables here, the class variables, we're going to swap these out now to use the appropriate values from here. You can actually choose which ones you want to show as well, but I'm going to just use the standard method here. I'm going to pass in all these values. There we go. And now you can use the struct for everything. And you can do the same for your other cases here. Don't forget for these switch statements as well. We're not using the hitbox type anymore. We are going to be using the one from the actual get here. So instead of using hitbox type, we use these. Which I'm going to bring this out a little bit. Then in spawn hitbox, which is a function within our hitbox actor BP, we're also using hitbox location here. We no longer want to do that anymore. We're going to use our hitbox data. And we're going to just basically, you can either get the specific value if you didn't want to actually show all those. Like you could break it here, and then you can choose the specific ones you want. Say I only want the transform. I can split this guy here, and I can pass in the location. Here's hitbox type. So guess what we got to do on this one? hitbox data, break, hide unconnected pins except for the type. We'll actually enable the transform on this one as well. We'll split it here. We can use the type here. We can get rid of this right here, and we can pass in the location to this guy. There you go, and something like this should do the trick where we're updating the hitbox data for the switch here for the type, and we're also using the location off that structure here for the set world location. And that's working for the create active hitbox. So everything is functioning as intended in here. However, we still need to do that for create proximity, create projectile, and create throw, as well as update the projectile logic down below. So if we go into our event graph for the hitbox actor BP, make the same changes that you saw up above. So for the two places where we take damage in this bottom set of logic for the projectiles, we'll want to update that to use the structure. And we'll want to update this hitbox type to use the hitbox data structure as well. Easy way to do this. We grab our hitbox data. Okay, we can break this. Hide all of our unconnected pins, and we only want the type here so that we can pass this in. And it's probably good enough, just like that. So we pass the proper type in, and then if it finds out it's a projectile, it does our standard projectile logic. We scroll over to where the take damage calls are, and then you know what to do by now. We can go ahead and remove these variables. Instead, we want to use our hitbox data. We want to, we could split it here, or we could break it either way, whatever one you prefer. So let's just make sure they're even here. Put it in between the lines. Also hide the unconnected pins, but we know that we're going to need the height, actually we don't need the transform because we don't care about the hit location in this specific case. Damage, hit stun frames, block stun frames, pushback distance, launch distance, and should cause ground bounce really could be involved here as well if you wanted to set that up for projectiles. We never did, but nothing wrong with it. I just never actually thought about implementing it there. And then all we have to do from here is match everything up. Okay, and then you can bring them down below, or you could have two separate cases of it, whatever you prefer. Just like that. And now projectile should also work as intended with the values. However, they will not be set up in the anim BP. So we'll need to go in and we'll need to fix up create projectile hitbox. So for the remainder of this episode, what I'm going to be doing is showing you all the edits I made to get all of my functions working with the new system using the hitbox data structure as opposed to the class variables. Now, I've actually taken the clips of everything that I've changed, all the important data. I have done a lot of cleaning in between, but just basically follow these short segments of what I'm doing. You see I'm attaching the select vector. You can see I'm going to grab the hitbox data. Basically just go step by step here. I'll do my best to explain it as it's going, but you should be pretty familiar with this. I didn't want to show this all live because of the fact that it would take seriously probably about an hour and a half to cover it all if I was covering it at the same pace that I was covering the other ones. So you can see what I'm doing here. Basically, this is for the proximity hitbox. You can see this is the create proximity hitbox function in my anim BP. You can do this for basically all of the create hitbox functions. They will have similar logic. You can see I'm going to select different pins and put in different data. For certain ones, specifically like the throw and the projectile, are pretty unique compared to the proximity and active hitboxes. So you can copy a lot of the logic, or you can go through and manually do it like I did for most of this here. Feel free to clean it up as you see fit, or change it to your liking. Just showing you one of the possible methods here that I used for all of these different functions. Important notes here, make sure that when you're making these changes, you do connect everything back up. It is easy that when you're disconnecting, you know, the old variables, you might forget to hook up any of your new ones. I've done that several times and was like, why is this not working? And it's because that I forgot to actually plug something back in after I disconnected it and connected new logic. So the proximity hitbox was incredibly easy because it's exactly the same minus some of the variables. Like you actually need less than you do in the active hitbox. But now we are in the create projectile hitbox. This one is a little bit different. The premise is essentially the same. You want to get rid of the old variables that were here, and you want to place in your structure and set the members in that. So all pretty basic stuff. But where the difference comes in is the projectiles themselves are a little bit different in terms of the location where they get spawned, and we edit that in the hitbox actor BP. But because of that, we also can change some of the things in this function when we create the hitbox on it that we won't need, such as removing this should attach boolean from this area, because again, we can't really attach it. If it's a projectile, it won't be coming with us. It's meant to leave. So just make sure you're only setting what you need to be setting. You can remove any of the pins that you don't want to set by clicking on the set members node and then unchecking them and hiding the unconnected pins. You want to make sure that you are hiding ones that you're not setting, otherwise you will reset the data in them. This is especially true. Make sure you're watching out for anything here with the damage, with hit stun, block stun frames. Those are the most important. I would say also be careful with the location, rotation, and scale. If you do need a specific location, rotation, and scale, maybe don't set it to, make sure you don't leave it blank. Make sure you do set it, or that you leave it alone and don't include it in the set members. Now this is the create throw hitbox, which is actually pretty easy. There's not a lot that we do in here because a lot of the damage comes when the throw actually finishes in the animation. But we still want to make sure that we create the actual hitbox with the correct location data and all of that. So don't forget to do that. And it's really the same strat between all of these, which is again why I didn't want to show you this live. Because even looking at it now, it's very repetitive. But I do like to show you everything that is done. That way you don't think I'm just skipping stuff. And hopefully to make it as little confusing as it possibly can be. And see, I'm doing a lot of cleaning up here with the reroute nodes and everything. You know that I'm picky and I like to straighten up nodes and use reroute nodes and try and do everything as cleanly as I can, and it doesn't always work out that way. But when we're making big changes like this, I definitely want to make sure I clean it up, otherwise I'll often forget to do it later. Quick note for the hitbox height here, you can choose it if you'd like. It's not required that you do. We don't normally in this series for the throw boxes, the throw hitboxes yet, but you could have different heights of throws if you'd like. That could be a custom mechanic. I just leave it at none usually to indicate a throw. Cool. And then once you actually get all that in, the last thing we need to do is we can remove our class variables. We no longer need these ones in the class, only the ones in the structure, because we have the hitbox data structure. So now we can get rid of these to clean up the class, reduce bloat, and also avoid confusion. When you do get rid of these variables, you'll also need to get rid of anywhere that we use them in the code. So we set them in the constructor for a lot of them. So go to your CPP file and remove them as well. This should now build and compile. At this point, you should check any errors that you have. I realized that I had skipped the hitbox actor BP, the simple collision check, because we use the hitbox type in there. And I've removed all those class variables, so now I just have to update this. What I'm going to do, you can probably guess by now, is I'm going to remove the hitbox type variable. I'm going to grab our hitbox data, and then I am going to grab the appropriate variable from it, which is the hitbox type. It's the only pin that I will have open. and then I'll plug it into these equal statements right here, and I'll just set up the appropriate checks again. So we want proximity, strike, and the bottom one is throw. Okay, and once we do that, we're actually all caught up. Now the series should work. Everything should work to date. Everything that we've had based on this new system, not the old system. So we'll use everything from the structs and the data table instead of using them through the class and the hard-coded variables. Make sure you also update the AnimBP to always use the data table. That I will not show all of them because there are many, and that would take very long. But yeah, there you go, guys. So that's how you can get this system set up. Anyway, guys, that's all I got for you. So thank you so much for watching. If you enjoyed, please subscribe. There's more for myself and the channel than anything else. I really appreciate it, and it's completely free. I want to give a huge shout out to my YouTube membership and Patreon supporters and subscribers. Thank you guys for all the love. It helps me keep working on these series as well as I can, as much as I can, and enjoy it while I'm doing it. So thank you so much. If you had any issues while watching this episode, please feel free to join the Discord community. There's a link in the description. It's completely free, and I'll be happy to get you sorted with any of the problems that you had. Anyway, guys, that's all I got, so thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.